So the next area of demonstration will be harvesting business rules. So why harvest business rules? Many of our customers are moving to, for example, off-the-shelf packages. Maybe they're going to take a part of their mainframe application and move that to one of these packages, and they need to understand, what am I missing? What are the functionality in the current application that I need to keep? And maybe I need to wrap some additional functionality around my off-the-shelf package to make sure I have everything I need. Any kind of automation for digital business automation or decommissioning applications. Some of our customers also are actually rewriting some of their applications, maybe building a .NET or a web application. And we've actually helped some customers do these processes. So we'll talk about how we can accomplish those tasks. Okay, so what's the traditional approach? So the traditional approach is kind of top-down, understand the code of each module and how things are executed in a system. And so what you end up with is a definition of how your current application set works. And most people are not looking for an architectural definition of how their current system works. They really want an architecturally independent definition of how the data is generated within application, what kind of processing happens, and what data is coming out. Our approach is to focus on a business-centered approach to this, and that is to, of course, model the application using evolveIT to identify the application-related business processes. This is a key element we'll talk about, where we get an understanding of how the business sees and understands the data that we're working with. And then we identify the interfaces, the actual data in those data structures that are being used, and then we will actually define the business terminology, capturing the meaning from the business perspective, and then we'll actually use our code slice technology to complete what we call a data logic trace to understand those paths, and then we'll combine this information into business rules. We consider this a dual path process, so the business analysis is very important to the process, and also the technical analysis. And as you can see throughout the process, the information is fed in both directions to enable the business rules to be defined. What's our methodology? So the real difference here is, rather than finding all the decisions in a particular program, we identify this data that's coming out of an application and we trace it across the application. So we slice across the application to understand how this data is processed and used within the application. And so what we end up with is a data flow analysis and a control flow analysis related to the specific data that the business is actually working with. So back to our demonstration again. And I'm going to bring evolveIT up. And I'm going to start with a similar process that we used before. We're going to use a data search. And I'm going to open up a data search that I've already have. You've seen it run. So we're going to talk about a loan amount in this case. So I'm going to open up this loan amount. And this loan amount happens to be a part of an annuity. And so a customer purchases life insurance, they pay up their life insurance, and they purchase an annuity. Once they have that annuity, they have the ability then to take out a loan against their annuity. And so we found one of the pieces of information is this loan amount. And in our application, we're looking at a loan amount that's actually sent out to a customer as a part of an annuity letter, so a letter that comes out each month or as they make a change in their annuity. So what I've done here is we've run this data search, we've found this loan amount field, and we've identified here in our two programs where loan amount is used. So again, I'm going to use a code slice. So one of the aspects we've talked about there is the idea of understanding what loan amount is, and so we've done that process. We've identified that business process, which has to do with the path of loan amount being a part of an annuity letter, a letter that's sent to the customer. So let's use our output loan amount, which is a part of our letter, and we're going to trace this data. In this case, we're going to trace it backwards. This is going to help us understand where our data is coming from. Where does loan amount come from within our application? So I'm going to expand this path, and we're going to see that the first thing we notice is we're seeing a read within this program, and we see a file that is read. And again, as I did before, I traced across the read-write boundary here, and we see a separate program down here that is writing our data, and we can continue down our path and understand where this loan amount came from. Again, we've got loan amount, so we'll continue on the loan amount path, and we see that the data is moved into loan amount. Again, we're tracing backwards, so we're understanding where does this data come from. And so we're seeing each step of the code path and how it defines this data. Now we found something really interesting. We found a compute. So I'm going to bring up the source code for our compute, and we'll see the source here at the bottom, which is always available. So it's going to compute this WS loan with a couple of other fields. We see those fields here, and we can continue down this path to understand where did this path come from. So there's an auto save feature popped up. So I'm going to continue on past this. Once we continue down that path, we see that this data record is coming from a few different calls. And so I'm going to expand one of the calls so we can see that we also can trace across the calling structures. So now we see the data flow of the record through the call back into our loan amount field, which is supplying one of the fields in our compute statement. Okay, so we've traced our path. We understand the compute now is where this calculation comes from, the input fields that relate to our loan amount being computed. And now what's important to know is also what are the decisions that determine when this compute's going to happen. And so I'm going to expand a set of decisions here, and there's a series of dependent decisions, and we're going to look at each one and understand what's important for a business rule about these decisions. So I'm continuing, and there's quite a few here, continue to expand the decision path. And what we're going to find is that one of the things we've learned, there's the top, is that the decisions that are close to the code many times are not necessarily business rules. These are decisions that relate to the code paths, decisions about which paths to take, and really don't have to do with the actual rules that you may want to understand. So let's look at the source code related to this decision. Okay, so in this case, we've got a decision that has to do with the issue date of the policy and this particular statement date. So we're trying to decide, in this case, this is a batch process. So each night it's looking at whether or not the issue date is greater than the statement date in order to determine if it's going to print our annuity letter. And so with this case, we see that that's helpful information to our rule process. Let's continue to look down the path here and see what other kinds of decisions. Okay, so this one's looking at, is this a qualified pension? So that's interesting to our rule. We want to know what are the paths relating to an annuity that's part of a qualified pension plan. The next decision has to do with a plan code. What kind of a plan is this? And of course, it's looking again at, in this case, if it's not a qualified pension plan, but it can be a different kind of plan. So we're learning all about the decisions that determine, I'm going to go back to the bottom here, what the decisions are that determine when we execute our compute statement. Now I'm going to look closer to the statement here, and we're going to see some of the source code that's directly related. So we see a decision regarding no more cash flows. So this is a process decision from a source code perspective that's determining, you know, is it finished with the process? Are there no more cash flows to compute? And so that process is not necessarily a rule, although interesting to learn about. The next one here is, again, looking at cash flow entries. So it's cycling through all the entries and determining, you know, has it completed the process building all the output data for all the different annuity letters. So again, not necessarily rule-oriented, but interesting information. And so the farther we get away from the actual source code statements, typically we'll find better information about the business rules. So hopefully this has given you a good overview and understanding of the way we focus on talking to the business, understanding the business process around the application, and then identifying the data that the users are interacting with so that we can create and understand the business perspective for the application. Then we use our code slice technology, tracing each of those paths for the data fields that are being used by the user of the application, and then we understand all the path information, providing everything we need to build our output information for business rules and our loan amount.